All right, so prereq for our purposes this week and every other week just means anything before today. So in week 2, technically week 1 material is a prereq. When we're in week 10, technically weeks 1 through 9 are prereqs for week 10. So what we're actually going to review today, or we're going to talk about today, is going to be a review from some stuff you saw back in week 1, and then we're going to chat about how you can apply it and how you're going to use it in week 2. So back last week, you had two types of special right triangles. The first of those, or one of those, was the 30, 60, 90 triangle. And so what you perhaps saw last week was a rule for the 30, 60, 90 triangle. So depending, I don't know how everybody may have labeled it during class or in their materials or whatever, but how I label this is across from the 30-degree side, I'm going to label that side as X. Across from the 30-degree angle, I'm going to label that side as X. Across from the 90-degree angle, I'm going to label that side as 2X. And then across from the 60-degree angle, that side gets labeled as X times the square root of 3. And this is a rule in kind of the same sort of way that the quadratic formula is sort of a rule. It's just a formula you apply to find solutions to a quadratic equation. And this is a rule you apply to find missing side lengths of a 30, 60, 90 triangle. And how we do that is by knowing, as long as we know just one of the side lengths, we can find the other two. The way we do that is by identifying what we know in the triangle we're working with and figuring out or comparing it to what it relates to in the rule above. So in our case, we have the hypotenuse, which is 10. We can set that equal to 2x, that's what it matches with from the rule, and solve for x by dividing by 2. What this tells us then is that the x side of the triangle is 5. The x times the square root of 3 side is 5 times the square root of 3. But we get x, and then we plug it in for x in the rule, using those to label our triangle below. Questions about how that works? We're going to do some more. So that's the general idea. Questions about anything we just said? Okay. So let's try another one. I'm going to change the orientation a bit. That doesn't change the rule. We've still got a 30, 60, 90 triangle, just some different sides are given now. So let's say across from 60 degrees, we've got 4. I'm going to give you a moment to see if you can identify the lengths of the other two sides. So from the rule above, so we have the side across from 60 degrees. From the rule above, we know that the side across from 60 degrees is x times the square root of 3. So what we're going to do is set x times the square root of 3 equal to the side length we know, and then we solve that for x by dividing by the square root of 3. That tells us that x equals 4 over the square root of 3. And so our 30-degree side, that's x. And then our 90-degree side, the hypotenuse is 2x. I'm going to come over here for a second off to the side. 2 times 4 over the square root of 3. That's 8 over the square root of 3. Again, just using those side lengths or using the rule to find the missing side lengths. Questions there? I don't I don't have a preference for my classes. That'd be something to check with your teacher about. Um, I don't know. I don't mind one way or the other. So we're gonna do one more of these, the one kind of version we haven't looked at yet. I'm gonna give you the length of the hypotenuse and ask you to label the missing sides. 30, 60, 90. The hypotenuse here, we're gonna put it as a 1. Deal with that. So Ryan, no, I can tell you that you don't need to rationalize them if you don't want to. Yeah. Sorry for not recognizing that you're in my online class quicker than I did. I've been over here trying to check for a minute. Um, it's hard to remember all the names just in the first week, but no, so you don't need to, for anyone in my class, you don't need to rationalize the denominators because I don't, to me, it's not that big of a deal. All right, so we have this is going to be the last one unless there's requests for another one. We've kind of looked at all three versions of this triangle based on the side lengths we can have. In this case, we have the hypotenuse. I'm going to recopy the rule just for us to match everything up one more time. 30, 60, 90, x for 30, 2x for the hypotenuse, x times the square root of 3 for the 60-degree side. In our case, 2x is equal to 1, which means x is a half, right? Divide both sides by 2, x is a half. So our x side is a half, and our 60-degree side is 1/2 times the square root of 3. We can write that as the square root of 3 over 2. Question there. I'm going to make a note specifically about this one. This last triangle, we're going to actually come back and revisit this one in just a moment when we start talking about the unit circle again. So it's kind of a heads up about that for what it's worth. I'm going to scroll it up and we're going to spend a little bit of time looking at the 45, 45, 90 triangle. Again, it works in the same sort of way. We have a rule for it. The rule is across from the 45-degree sides, we have x. Across from the 45-degree angles, we have x. Across from the 90-degree angle, we have x times the square root of 2. So what that means is if we know one of the side lengths, we can find the other two. So let's say across from one of these 45-degree angles, that side length is 7. So according to the rule, x is 7. No work to solve that, just pointing it out. That means the other x side is also 7. That means the hypotenuse is x times the square root of 2, so 7 times the square root of 2. Questions there? Okay, let's do Another one, of course. Let's say we have another 45, 45, 90 triangle. I'm going to change the orientation a little bit. It doesn't change the work we're doing, of course. It just, maybe think about it a little differently. But we have a 45, 45, 90 triangle. The hypotenuse is 1. I'll give you a moment to find the two missing sides, if you will. So for this one, we have the hypotenuse that's x times the square root of 2. So we'll set that equal to 1. Dividing by the square root of 2 tells us that, tells us that x is equal to 1 over the square root of 2. So our two missing sides are both x's, so 1 over the square root of 2 for each of them. Questions about that one? We're also going to come back to this triangle momentarily and use that inside of the unit circle, inside of our unit circle conversation as well. Okay. Any requests to chat more about the 30, 60, 90 triangle or the 45, 45, 90 triangle? We certainly can. I don't know how much time folks may have spent last week in class or practicing or otherwise. Certainly can spend more time if you want to. My recommendation is, they're kind of to just use the rule that goes with them. There are two cool questions related to this. They're on page 5 of the lab manual, numbers 14 and 15. I think it's 14 and 15 from page 5. They are in some way an explanation of where the rules come from. Yeah, so Maddie, eventually that's what we're gonna chat about the unit circle and then talk about how to use it to answer questions like that. You can use a triangle to answer questions like that too. Yeah, so that's how so I create the unit circle from those things, from these two triangles. So the unit circle, what it is a circle that has a radius of 1. And essentially it's a summary of special angles, sine, and cosine ratios. And special angles, those are angles that are multiples of 30 and 45 degrees. So the exact angles we've just been looking at, in other words. Let's see, I used to have, I think I closed this. I'm going to actually put a screenshot in the chat for not, it'll permanently be there, I guess, but we're going to chat about it for a second. On page 93, 94 of your lab manual, there is a unit circle. You can find a unit circle, just go to Google and type unit circle. There's a ton of them that'll pop up that way too. But your lab manual is another option. So page 94 has this unit circle on it. And what it is just a collection of angles and ordered pairs associated with them. And those ordered pairs tell us sine and cosine ratios associated with that specific value. So for example, I'm going to draw this and then erase it in just a second. But on the unit circle, we have a 30-degree angle. There's an ordered pair there. It's the square root of 3 over 2 with a half. And that ordered pair tells us the cosine and sine ratio for 30 degrees. So cosine at 30 degrees is the x coordinate, that's the square root of 3/2. Sine at 30 degrees is the y coordinate, that's a half. Oh, where's everything at? Sine at 30 degrees is the y coordinate, and that's a half. That's the whole point of the unit circle, is to literally to look at it and read back these ratios from it, or maybe to get some ratios to use to answer some other type of question. But someone in the last session was asking, how do we do, how she said that she finds it hard to do it without looking at a circle. I want to be super duper clear. I think you should. I think it's a good idea to look at the circle. For a test, it's not going to be given. My recommendation, you take a minute or two at the beginning of the test and just draw the unit circle. If I were sitting down in a classroom or maybe at the testing center taking this test, I would create a unit circle before I even wrote my name on the test. I think especially for test 1 and test 2, since someone pointed it out in the chat, we spent a lot of time with me emphasizing it last week, but you don't get calculators on test 1 or test 2. The whole reason is because you're supposed to, all of the angles on test 1 and test 2 will be 30, 60, will be multiples of 30 and 45 degree angles. So 30 degrees, 60 degrees, 120 degrees, 315 degrees. All of the angles on the unit circle, though, those are the types of questions you're going to see. Those are the types of angles you're going to see on test 1 and test 2. So the unit circle would be a really great tool to have, but you do need to create it yourself. Okay, so that's kind of those are kind of the questions we're going to be answering. I'm going to take this away. We'll chat about creating the circle and then spend a little bit more time talking about those questions and how we can answer them. All right, we're going to do this in questions about that before we move on. All right, so we're going to break this down into 4 different categories. The first one is the 30-degree angles. And what I'm talking about, so there's 4 angles that create a 30-degree triangle, or that create 30 degrees connected to the x-axis. What we're actually going to be doing is creating 4 30, 60, 90 triangles. Oh, what am I missing? So we're going to create 4 30, 60, 90 triangles. And we know one of the side lengths of each of these triangles. Anybody know which of the side lengths we can label up front? Goes back to something we wrote earlier from up here. The one, yeah, where does it go? The hypotenuse, let's talk about the blue one. Does it go for the hypotenuse, the bottom side, or the right side? Yeah, the hypotenuse. It goes for the hypotenuse because we said that the unit circle has a radius of 1. This hypotenuse is a radius of the circle, right? It starts at the center of the circle and it extends to the outside of the circle. It's a radius. If I draw, it's a radius. We actually labeled this triangle earlier. I'm going to scroll back up one more time. That's this triangle. That's the one I put a blue box around and said we're going to talk about it later. We've already labeled it. We'll get to why labeling it is important in a moment. If you want to, you can go back through the rule and label the sides again if you want to do that. I'm just going to recopy them because we did already do it. So the right side is a half. The hypotenuse is the square root of 3/2. What we're interested in, we said it as a couple minutes ago, we're interested in that ordered pair. Well, think about the ordered pair. And what an ordered pair is, it says starting from the origin, you should travel this number of units to the right and this number of units up. Those are literally the dimensions we just labeled, the side lengths we just labeled on this circle. we should, to get to that blue point on the, on the circle, we should travel the square root of 3 over 2 units to the right and half of a unit up. So if you look at the circle I put in the chat, that's where that ordered pair comes from for the 30-degree angle. And what's interesting, or questions about that?
So is it sort of like the opposite of like rise over run? Like, I'm okay. I think I'm.
I don't know. I don't know that. I don't think I would describe it that way. So all I'm doing is just taking the bottom value, that's the x coordinate, taking the right value, that's the y coordinate. I don't know that I would. I'm not seeing the rise over run connection. I'm not saying there isn't one.
I think I'm just
I'm
having
not
like.
seeing it.
Yeah, I think I'm just having a brain fart. Sorry. Thank you.
That's okay. So an interesting thing about all these other triangles, right, just to point out, they're the same triangle. They're all 30-degree triangle. They're all 30, 60, 90 triangles with the 30-degree side connected to the x-axis. So they all have 1/2 for their either left side or right side, depending on where we're at. And they all have the square root of 3 over 2 for the side on the x-axis. Again, depending on where we're at. So every one of them has a similar ordered pair. This red angle, it's left the square root of 3 over 2 units, and then right, or then up half a unit. The orange one here at the bottom, we again went left the square root of 3 over 2 units, and then we went down half a unit. And then the green one over here at the bottom, we went to the right the square root of 3 over 2 units and went down half a unit. The only thing that changes in any of these ordered pairs is the SIG and the sign for some of these numbers. In quadrant 2, the x coordinate is negative. In 3, x and y are both negative. And in 4, y is negative. But all of these ordered pairs are really similar, with the exception of some values being negative depending on the quadrant. Questions about the ordered pairs. And again, if you have the circle open, or at least somewhere you can view it, you'll see that all of these, that the four ordered pairs we just wrote are the 4 for the 30-degree angles on the circle. Questions about that? The piece where we've yet to label is the actual angle measures here. We do need those. That's part of the process of reading the unit circle. So think back to last week, an angle in standard position has an initial side on the positive portion of the x-axis, and then you rotate around and you have a terminal side. Right? That's the rotation we're talking about. Every angle in standard position, you start on the x-axis and then rotate whatever number of degrees you need to rotate. So we're always interested in these angle measures in standard position. So the red angle, we're interested in this measure, the one that I just drew, that rotation, from the x-axis over to the terminal side of that angle. If we were to rotate all the way around to the negative portion of the x-axis, how many degrees is that? Starting over here at 0 and rotating all the way half of a circle. How many degrees are in half a circle? Anybody remember from last week?
180.
180. So for our triangle, though, we didn't quite go that far, right? We stopped 30 degrees before that. So 180 minus 30 tells us that this red angle is 150 degrees. What about the orange angle? Same idea. Yeah, yellow's next. So if we go to the yellow angle, we passed 180. Specifically, we went 30 degrees beyond it. Maddie put it in the chat. That one's 210. And then for the green one, same idea as the red one, actually. If we go all the way around the circle, we make a whole rotation, that's 360 degrees, but we don't quite go that far. We stop 30 degrees before that. So that green angle is 330 degrees. So now, in fact, if you were to look at the circle, we have all the information for these four angles filled out. We have the ordered pairs, and then we have their angles. Questions where about where the angles come from, or about where the ordered pairs come from. Okay, we're going to keep going kind of through the same process. We're going to do it now for the 60-degree angles. And once we wrap this up with the 60-degree angles and then with the 45-degree angles, we're going to take all of them and put them together to actually create the circle. So that's strange. Next, we'll look at the 60-degree angles. So in each of the quadrants, we have a 60-degree angle. We've actually already labeled these triangles too. That's the other one in blue. Oh, sorry, we didn't do that one in blue. I take that back. But we have labeled the triangle because it's the same triangle from earlier. Again, we know the hypotenuse has a length of 1. Oh, dang it. I'm going to undo all of that for a second. I meant to do it all in colors. So we can kind of, the picture just gets so jumbled. I like to use the colors to kind of try to coordinate some stuff. So red, blue. Okay, so we've kind of labeled these already, though. It's still a 30, 60, 90 triangle. Let's just think about the one over here in quadrant 1. It's still a 30, 60, 90 triangle. The hypotenuse is still 1. And across from the 30-degree side is still a half. Across from the 60-degree angle is still the square root of 3/2. None of that changes, just we're kind of manipulating the triangle a little bit, but the side lengths are still the same. So across from 60 degrees is the square root of 3/2. Across from the 30 degrees, that's a half. So that tells us that the ordered pair here, the side along the x-axis is a half, the side along the right side of the triangle, so the vertical side, the y side, it's the square root of 3/2. For all of the other points, for all the other angles, the ordered pairs are moderately the same. I'm going to go ahead and jot those in. The only difference, just like before, is negative signs based on the quadrant we're in. So in quadrant 2, the x coordinate is negative. In quadrant 3, x and y are negative. And in quadrant 4, y is negative. So we're mostly there. You're thinking of the information on the circle that we've now labeled on ours. We still need the angle, so in quadrant 1, 60, that is the angle. Oops. That's weird. So I got this new pen the other day, and I'm just learning how to use it, but apparently if I tilt it down, it erases bigger than if I hold it straight up. That's weird. Okay, 60 degrees, that's our red triangle, our red angle. Same thing we did before, we're going to use that to figure out the angle in quadrant 2. If we go all the way down to the x-axis again, that's going to be 180, but we don't go that far. We stopped 60 degrees above that. 180 minus 60 tells us that this blue angle is 120 degrees. For the yellow one, if we go to the y-axis, or to the x-axis, 180, but we went 60 degrees beyond that. 180 plus 60 is 240. For the green one, if we go all the way around a complete rotation, it's going to be 360 degrees. We didn't quite go that far. We stopped 60 degrees earlier. 360 minus 60 tells us this angle is 300 degrees. Questions about any of those angles or the ordered pairs? And we would use this, right? We would construct a unit circle, and eventually would have all these angles that we're going to go through, but we would just read values off of it. So sine at 300 degrees, we would go to the 300-degree angle and get the sine ratio for that angle, which is the y-coordinate. So sine at 300 degrees is negative square root of 3 over 2. Those are the kinds of questions we use the circle to answer. Cosine of 60 degrees will go to 60 degrees. Get the cosine ratio, that's the x one. Sine at 60 degrees is a half. Questions there? Okay. Last one of these, and then we'll kind of synthesize everything into one big picture. 45, 45, 90 triangles. We haven't, or sorry, I don't mean triangles, 45-degree angles. So we have this unit circle still. Every quadrant has a 45-degree angle in it. We did draw this triangle earlier too. Let's scroll back up and just point that one out again. I'm going to change it a little bit. So I'm going to recopy this triangle and point out just one thing about it. So we drew it earlier. We had this. We did 1 over the square root of 2, 1 over the square root of 2, and 1. That was one of our answers earlier. We had the question about rationalizing denominators, and I said, to me, my preference for students in my class is that I don't care if you rationalize or not. If you want to, you can. If you don't want to, you don't have to. I don't rationalize, so I'll provide answer keys for the test once everyone, once they're graded and returned to you. If you look at my answer key, none of my answers are going to be rationalized. However, we're going to chat about rationalizing here just because we're looking at a unit circle, and it's going to be much more common that you find a unit circle that has rationalized denominators. So what it means to rationalize the denominator is to remove the radical from it. So 1 over the square root of 2. To rationalize that denominator, we multiply the top and bottom of that fraction by whatever radical is in the bottom originally. So we're going to multiply the top and bottom by the square root of 2. That gives us the square root of 2 over 2. Makes no difference to me one way or the other if you actually do this, but chances are exceptionally high if you just Google unit circle, or if you open the one that I sent in the chat, the denominators for these angles are rationalized, and so I just like to make my circle match those. But if you don't want to rationalize again, it doesn't make a big difference either way. I don't know. I don't know. That's why I don't care if my students do it or not. That's why I don't do it. I don't know the purpose. Kind of the point is that it's inappropriate to have radicals in a denominator. But I think that's pretty subjective based on who you ask. I don't think it matters. So rationalizing is certainly a thing. I mean, that was really heavily emphasized to me, at least back in high school. It's never really been that big of a deal since high school, in any math classes I've ever been in. But my high school calculus teacher, rationalizing denominators was really important to her. And so I learned to do it, and we did it. But I don't, it doesn't do all it does is remove the square root from the denominator. And to me, that's not a big deal. But if you ask 100 people, I suspect it's about 50-50. 50 folks will say it is important, 50 folks will say it's not. So it just kind of depends. That's why earlier, check with your teacher about rationalizing. If that's an important thing for them, just make sure you're doing it. Okay. But Maddie, hopefully I've answered your question. The point is just that it removes the radical from the denominator. That's the goal that it accomplishes. So I'm going to label all of these side links using that rationalized number, just because that's typically how you'll find the unit circles if you just randomly Google one and open it. So the square root of 2 over 2, but what's cool is that all of the sides are actually the same, right? They're both x's if you think back to the circle, to our triangle, I mean. So all of these sides are the square root of 2 over 2. Which makes it pretty convenient actually to label. The x and y coordinates are both the same, square root of 2 over 2 with the square root of 2 over 2. And again, if you didn't rationalize, you're certainly free to put 1 over the square root of 2 here. The only difference between any of these coordinates is that the quadrant we're in dictates whether some values are positive or negative. So in quadrant 2, the x is negative, and 3, x and y are both negative. And then in quadrant 4, one more time, the y is negative. Questions about the ordered pairs or how we got them? We'll label the angles the same way we did earlier as well. 180 minus 45, that's 135 in quadrant 2. In quadrant 3, just like we've done the last 2 times, it's 180 plus 45, that's 225. Just like we've done the last 2 times for quadrant 4, 360 minus 45 is 315. So we could answer cosine at 135 degrees. We'd get the x coordinate from there is negative square root 2 over 2. And again, that's how we use the circle, just by reading these numbers off. We could put all these together, and we certainly can, but to create the unit circle, you would take each of the 3 circles we've just drawn and kind of overlay them one on top of the other, and it would probably make a big mess if you were actually doing it with the circles I drew. But the point is taking all these values and putting them into one big circle. That's the unit circle. And again, like I said earlier, my thought that it would be helpful to draw a unit circle at the beginning of the test, just so that you can look back at it. And you're not, if you're in the middle of thinking about a question, it seems to me that it would be awkward to have to break that train of thought to then go and think about the circle, to then come back and think about the question again. That's why I said if it were me, I would just draw a circle at the beginning of the test and get it out of the way, and then just go about my business of taking the test after that. Questions, I'm going to make a couple of additional points about the circle, but questions about how we got any of these numbers or angles or anything. All right, so I'm going to make a couple of points. Couple of tips, maybe. So let's say we're trying to draw a unit circle. We know that there's a 30, a 45, and a 60-degree angle. We need to label them. And I don't, so my iPad's updating kind of slow. 30, 60, or sorry, 30, 45, 60. If you can label quadrant 1, you can label all the other ones, right? So if you, for some reason, have so you can either draw these triangles or think about these triangles. That's the kind of way we just did it. You can memorize the unit circle. That's totally fine. No issue or no downfall for doing that. Whatever helps you get the thing drawn. But if you can label quadrant 1, you can label all the other ones, because like we've already said, they all match. So literally the 3 angles in quadrant 2 match in the exact same order the angles from 1. This angle closest to the x-axis is the square root of 3 over 2 with a half. The middle angle is the square root of 2 over 2 with the square root of 2 over 2. The top angle is 1/2. I can get it to draw with the square root of 3 over 2. The only change in quadrant 2 is that x needs to be negative. Then if you, I'm not going to do this because we'll just clutter the picture so much, but if you take all those and flip them down to get the 6 angles along the bottom, again, you're recopying just the ordered pairs, changing the negative signs as needed. The questions about that. And we spent a lot of time talking about it. It's certainly not something that would take necessarily 50 minutes to draw. I mean, a couple minutes at most. I'm going to point out one last thing. We actually haven't labeled 4 of the angles yet. The ones on the x-axis and the 2 on the x-axis and the 2 on the y-axis. Since the unit circle has a radius of 1, we can get those. We don't need a triangle to get them. The ordered pair over here at 0 degrees, it's got an ordered pair of 1, 0. At 180 degrees, it's -1, 0. At 90 degrees, it's 0, 1. And at 270 degrees, it's 0, -1. Again, solely because the radius of the circle is 1. And for those 4 points, those 4 angles, we're traveling either directly left and right or directly up or down. Certainly no triangles for that. One last thing I'm going to point out, if you're going to memorize this, and even if you're not, it maybe is helpful to see it, but all of the denominators are 2. If you're memorizing this whatsoever, no need to spend any of your storage space for memorizing the denominators, because they're all 2. I mean, you need to know that they're 2, but it's not that you're memorizing 12 different denominators, just that they're all 2. The numerators for the x fractions count down: the square root of 3, the square root of 2, the square root of 1. The numerators for the y fractions count up: the square root of 1, the square root of 2, and then the square root of 3. Or what, I don't know what, if any of this stuff kind of meshes well with what you're planning to do or what makes sense to you, but those are the things that I can point out for memorizing, certainly the things I can point out for using the triangles to draw the circle. And again, what we would use this for, we've answered a couple of these along the way, but if we need to figure out sine at 90 degrees or cosine at 150 degrees, and we can just keep repeating, but they're all cosine at 45 degrees. Right, we would just go to the circle, we would find our angle, 90 degrees, and get its sine ratio, that's the y one. So go to 90, get y, that's 1. So sine at 90 degrees is 1. For cosine at 150, we'll go over to 150, that's this one. Cosine is the y coordinate, so cosine at 150 is negative square root of 3 over 2. Cosine at 45, we'll go to 45. Cosine is the x, so that's the square root of 2 over 2. Or again, I think I said it this way several times. We're literally just reading numbers off the circle. Find your angle, give the x or y value you need. That's the sine or cosine ratio. Questions about that? Or about anything we said, questions about these triangles or questions about the circle itself or how we can read it or actually like literally anything about it. That wraps up what I've got planned. We've got 35 minutes of time to answer any questions you have about anything you want to talk about. I sent the second survey link in the chat. Like I said at the beginning, those are super important. If you can complete that now would be cool. Unless there's something that you want to chat more about, something I should explain better, we can certainly do that if you'd rather wait on the survey until we explain it again. But when you're ready, if you'll do that, that'd be really cool. But the rest of our time, we can answer any questions you have about this or about something from last week, about WebAssign, about the live manual, about an example from class, literally anything that you want to chat about from 172 is up for discussion. My tips, recommendations, I don't know. Any of that sort of stuff is what our time is for. If you don't have any questions or if you're ready to go, obviously under no obligation to stay, so feel free to leave when you're ready. Just please do my survey before you leave. But stay as long as you want. We'll answer any questions. Otherwise, you're free to go when you're ready to do that. If you have questions, ask them out loud, type them in the chat. I have a live manual open if you want to chat about something from the live manual. Just real quick about that. Page 12 is an excellent page 12 is excellent practice for this. If you're in my seated class, we will be using page 12 during class this week. If you haven't looked at page 12 yet, and just want more practice, page 12 is excellent practice for this topic. You're welcome. Thank you all for coming. If you have other questions, you can send me a chat or send me an email, whatever, however you want to do it. Ryan, yeah. Do you have one in mind or just for what? Was it one of my word problems or was it one from WebAssign or something? Yeah, you're talking about what pages 9 and 10 maybe? Yeah, well, I would recommend more to stick on page 9. So page 10, those problems involve a calculator or require a calculator, and I just wouldn't, just since your test doesn't allow a calculator, I would not spend too much time worried about page 10 necessarily. So let's look at page 9. I'll just do number 1 unless you have a request for something different. Number one is about a cat stuck in a tree, or in a building, I mean. So I'll put a screenshot of the question in the chat and give you a second to read it. What's going on in number one off of page 10? Is that there's a cat in a building, and the cat is approximately 70 feet high. So we have the building. Let's just pretend the cat's sitting on the top of the one I drew, and it's 70 feet high. Well, maybe Ryan, so this doesn't actually use the word angle of elevation, so I don't know if you want me to keep doing this one or not. I thought it was actually going to say angle of elevation, but it does not. Do you? Yeah, number two at least has the word in it, so I'll send a screenshot of two for anyone who wants to read. Yeah, two's probably more what I should have started with. But if anybody wants me to finish one, we'll certainly do that too. So here's number two. These folks are in a lighthouse. Still off of page 9. So they're in a lighthouse. When they get to the top of it, they're 158 feet in the air. They can see their beach house, so it's going to be somewhere over here. And they can see it with an angle of depression of 60 degrees. So angle of depression, what that means is if you're at the top of this lighthouse, I'm going to draw another lighthouse over here. If you're at the top of it and you look straight ahead, you have to depress, meaning push down. You have to depress your gaze by 60 degrees. You have to depress your line of sight 60 degrees. That's what angle of depression means. So you have an angle of elevation as well. We'll chat about that one in a second. The angle of depression from the lighthouse to their beach house is 60 degrees. We're told 158 feet. So the question is, what's the distance between the lighthouse and the beach house? To answer the question, we're going to use a 30, 60, 90 triangle. This top angle is 30 degrees. That's because 30 and 60 make 90. The bottom angle is 90, so the right angle over here is 60 degrees. So this is a 30, 60, 90 triangle. Across from 60 degrees, we've got 158. Think back to the rule we drew earlier. Across from 60 degrees, we have x times the square root of 3. Across from 90 degrees is 2x. And then across from 30 degrees is x. Just like we did before, I'm going to set 158 equal to x times the square root of 3. To find x, we'll divide by the square root of 3. And that says that x is equal to 158 over the square root of 3. So that's our missing distance here. Yeah, for sure. So angle of elevation, angle of depression, those are two terms. Probably saw them last week. So angle of depression, we just chatted about that. I'm going to mention it again. So I'm going to kind of make up a definition. But from a horizontal line of sight, depress, or I don't know a better word, I shouldn't use depress though, lower your gaze. I don't know, great word. I don't want to use line of sight. So again, I'm going to redraw the same picture I already drew, but let's say you're a person. Directly in front of you if you need to look down at something on the ground over here, you're going to have to use an angle of depression. Anytime you're looking at something below where you are, it's an angle of depression. Angle of elevation is virtually the same definition from a horizontal line of sight. Raise your gaze. No, it's making poetry. So if you're looking perfectly, and you would use this to look at something above where you're standing. So if you're looking horizontally and you need to see something above where you're at, that's an angle of elevation. I have one more point I'm going to make about these two, and that is, imagine if you're, let's say you're on a building looking down at someone on the ground. Whoops, they ain't going to meet that way. Actually, let me take that back. Your angle of depression has to match that person's angle of elevation. Right? If you're on a building looking down at someone, whatever angle you have to look down at them is the same angle they have to look up to see you. Otherwise, you're going to miss each other. If you're looking down at 30 degrees and they're looking up at 50 degrees, right, you're going to kind of your line of sight's going to kind of shoot past each other, in the sense that you could only see that one little section of your field of vision. So I'm going to kind of take that, and maybe this isn't anything we need to be talking about, but I'm going to take that and come back up to the picture and just point out that's exactly what was true in our picture. So we had an angle of depression of 60 degrees. So to see from the lighthouse to see the beach house, we depressed by 60 degrees. Well, if you're at the house looking up, you have to elevate by 60 degrees to see the lighthouse. So they're always going to match. The angle of depression kind of floating in space up here above the triangle is always going to match the angle of elevation that's actually going to be inside the triangle. For what all that's worth to here. So Ryan, this we got here because you originally asked for questions off of page 9. Are there other ones? Anything else we can do from page 9? Anybody else have other questions? Or we can keep chatting about this. I don't know if I took up too much time talking about it or not. Yeah, for sure. So I've since scrolled back up to the question. Obviously, if we need to go back down to the definitions or something, I can do that.
Could we do the first question about the cat?
Yeah. So what's happening there, start of the picture, I'm gonna go back up to it. We have a cat 70 feet in the air. We have a fire truck that's 10 feet tall. And they have a ladder. I think it's 10 feet tall. The fire truck is 10 feet high and the ladder is 100 feet long. The ladder is extended at a 30-degree angle. Our question is this ladder going to reach up to the cat? So essentially, we're working with this triangle here. I'm going to draw it a little bigger for us. So the hypotenuse is 100 feet. We have a 30-degree angle. The question, what we really want to figure out is how far is it going to extend on the right side? Well, that's another 30, 60, 90 triangle. So in our case, 2x is equal to 100. So x is 50. So that means that the right side of our triangle is 50. So coming back way over here to our diagram, I'm going to label this little blue piece, it's 50. Combine that with the 10 that's at the bottom, that tells us that the ladder only reaches 60 feet tall, or 60 feet up the building. So it's not going to reach the cat because there's an additional 10 feet to get to the cat. So
Thank you.
Yeah, so what would need to happen to reach the cat is scoot the truck closer to the building and increase the angle of elevation. That'll make it certainly can reach the cat, just not in its current position.